Number 4 is a projectile motion problem where they give you the initial launch angle of 37 degrees. They give you the initial launch velocity is 65 meters per second. They tell you it's being launched from the top of a cliff that's 125 meters above the ground. We don't know the distance away from the cliff, x, that the projectile will land. And that's all the information that's given. Part A says determine the time taken by the projectile to hit point P, where it lands. So, for two-dimensional motion, which is what projectile motion is, you have to split the problem up into the two separate dimensions and only use x variables in the x dimension and only use y variables in the y dimension. The one variable that you can use in both is time, because if something has been moving for 5 seconds, then it's been moving for 5 seconds in both dimensions. And that time always can be used in both horizontal and vertical, or x and y. But every other variable should stay in its own column. So when I work these, or when you work these, it could be helpful to use a table and only keep horizontal things in the x column and only keep vertical things in the y column. And so it also helps to define what your axes are. If I come along and read your problem and you use something that was not what I would have assumed you should use, then it's very hard to read your work. So in the x direction, before you do anything in the columns, it will help to split the initial velocity into x and y components. So this is the initial velocity in the x direction, this is the initial velocity in the y direction. This is going to be 65 cosine 37. The initial velocity in the y direction will be 65 sine 37. And this is just breaking down the right triangle. Okay, so the information we know in the x direction is that the velocity will be 51.9 meters per second. We know that the initial velocity in the y direction is 39.1 meters per second. In the x direction, we also know that if it's projectile motion and the ground is horizontal, which you can always assume unless they state otherwise, then gravity only acts straight down in the negative y direction. So there's no forces pushing left and right, so there's no acceleration left and right. So in normal projectile motion problems, the x direction or the horizontal direction will never have an acceleration. If it did, it would be clear from the problem that it wasn't normal projectile motion, and it would be clear that you would have to include some acceleration here. But the acceleration in the y direction will be negative 10 meters per second squared. What else do we know? We know the displacement. Well, we don't know what the displacement in the x is going to end up being because we don't know where it lands yet. So that's a question mark. But we know the displacement in the y direction. If it starts at the top of the cliff and it ends on the ground, that displacement will be negative 125 meters. Okay, so part A is asking how long does it take for it to hit the ground? We don't have enough information in the x column to really solve that because we don't know how far it is. If we knew how far it was, then you could find the time in the x column. So try the y column. We know initial velocity, we know displacement, we know acceleration. There's immediately one equation that jumps out to me that would let us solve this problem. And that is displacement in the y equals initial velocity in the y times time plus 1/2 times acceleration in the y times time squared. If you plug in the numbers, the only thing we don't have in this equation is time. The minus 5 comes from 1/2 times negative 10. So if you rearrange this and solve for t, you will get 10.3 seconds or negative 2.44 seconds. And generally, if you get a negative time from solving a quadratic, you can throw that one out because in the physical model of the situation, that mathematical root has no meaning. And so you choose the positive root. There are certain situations where you might end up choosing the negative root, but we haven't encountered them. I doubt IB Physics throws one at you. It is up to you how you solve quadratic equations. You can do it by knowing the quadratic formula and just doing it manually. It just might take a little longer. Otherwise, you should maybe use PolySimult. It probably would be faster and save you time on exams. So the answer to part A is 10.3 seconds. That's A. B says, determine the range x of the projectile as measured from the base of the cliff at, and then the next sentence is for C. Okay. So they want you to find how far out it lands from the cliff, or x, which is simple because in most projectile motion problems, the x direction has no acceleration. So it is just speed equals distance over time, pretty much. You can still use Sx equals uxt plus 1/2 axt squared. It's just that it will immediately reduce because there is no acceleration in the x direction. So the displacement in the x direction will be 51.9 meters per second times the time that we just found, 10.3 seconds, which is 534.6 meters. That's the displacement in the x, which in this problem is also called x, 534.6 meters. That is the answer to B. Then C says find the horizontal and vertical components of the velocity right before the projectile hits the ground. And so this kind of part of motion questions, sometimes students get confused because they think, well, there's the ground there, so when it hits the ground, obviously it's not going to be moving, so no velocity. That's not what they want you to do. You're not actually studying the collision with the ground. You are assuming that the particle gets, or the projectile gets to point P, and you're finding the velocity as if it didn't collide with the ground, or at the instant right before it collided with the ground. What are the components of the velocity? And so those velocity components are what you would use if you did try to study that collision, which we aren't doing. But so assume there's no ground. What would the velocity at point B be? And so really you're trying to find final velocity, which Vx, Vy. Vx is a lot easier than Vy because we already said there's no acceleration in the x direction. So whatever velocity it has at any point, that's the same velocity it has at every other point because there's no acceleration, so there's no change in velocity. So Vx is the same thing as Ux, which is 51.9. Vy isn't hard, but you have to do a little bit more work for it. So there is accelerated motion in the y direction. So is there one formula we can use right off the bat from the information that we have that would get us the final velocity? You got two options. We know the displacement and the acceleration. We know the initial velocity. So you could use v squared. So Vy squared equals Uy squared plus 2Aysy. But now that we know the time, you could also use the fact that final velocity is initial velocity plus acceleration times time. These are all in the y direction. So either of these choices would allow you to calculate the answer. It's up to you at this point which one you use. You should get the same answer. I'll use the second one. So Vy equals initial velocity is 39.1 plus negative 10 times 10.3. And that equals negative 63.9. So that's part C. Oh, well, we have what we need to finish part C. Now that we know Ux and we know Vx and Vy, you can construct the total final velocity out of those two components. So Vx is 51.9 in the x direction, and Vy is negative 63.9. So that's the x component, that's the y component. The total final velocity is going to look like this. And the magnitude of it will be V equals the square root of the square of both of these. Squared equals .3. So that's 82.3 meters per second, and then you just got to find this angle, which will be the tan inverse of 63.9 over 51.9, which is 50.9 degrees, and that is clockwise from the negative x-axis. So it looks like this. If you translated this into the conventional way of measuring angles, it would be 360 degrees minus that. So 360 minus 309.1 degrees counterclockwise from the positive x-axis. Either of these would work for defining the angle. So all combined, the components, finding the components answers part C. The magnitude of the velocity being 82.3, that answers part D. And then this angle answers part E. Finally, F says find the maximum height above the cliff top which the projectile reaches. So we'll work F here. That's in the y direction. So really, if you had room, you would keep working this in the y direction. The thing that denotes the top of the path will be that the vertical velocity is 0 at the top of the path. Just like if you took a stone or a baseball and threw it straight up, at the top of its path, it momentarily switches from going up to going down. So in one instant, it has 0 velocity, and then it starts coming back down. So wherever the final y velocity is 0, that will be the top of the path. So if you do this with Vy squared equals Uy squared plus 2Ay Sy, plug in 0 for the final velocity because that's what happens at the top of the path. Initial velocity is 39.1. And then the displacement in the y direction will be the answer that F is asking you for. So if you solve that for displacement in the y direction, you get 39.1 squared divided by 20, which is 76.4 meters. All right, that's the end of the problem. There aren't many other things that you could be asked in a projectile problem than all of the different parts of this one. So if this makes sense, you're probably ready for projectile motion questions.